Eto na ang ating bagong project. Oh, nag-upload na tayo ng code sa ating Arduino microcontroller. Kaya, pwede na nating kabitan ng 9 volts. Yan na ngayon ang supply ng Arduino. Okay? At, ang in-upload nating code ay PWM, Pulse Width Modulation Generator. So, meron tayong PWM na upload na code galing sa Arduino code. Sandali naman! Ano na naman yung ginagawa mo yan? Bagong project ito. Meron tayo ditong microcontroller. Ay, ano naman ang gagawin mo dyan? Ang gagawin natin dito, ito ay DC motor. Paikutin natin ito. At yung mga circuit na nakakabit dyan, dito, merong MOSFET. May resistor, may LED, input LED indicator. Okay? At saka potentiometer. Ano naman ngayon yan? Yan yung project natin bago. Gawa tayo ng speed control ng motor. Ang style dito, yung sa MOSFET, yung output ng MOSFET, output side, may sarili siyang power, 3.7 volts. At sa Arduino, merong 9 volts. So, dalawa siyang supply. So, may separate supply para sa driver. Ito yung pinaka-driver ng motor. Testingin natin. Yun o. Uy, teka. Testingin na natin. Pag inikot ko yan, ano nangyari? Ayaw? Yun. Yun o. Meron siyang indicator. Yun ang indicator yan, yung blue LED. Ibig sabihin yan, meron tayong signal sa ating driver. Ayan. Yung pinaka full speed niya. Yan, mabagal. Kung mabilis naman, yan ang full speed. Diba? Nakokontrol natin yung speed ng motor. this is now the DC motor speed controller PWM Arduino schematic diagram of our project. In our project, we are using Arduino Uno, and we uploaded the code. What is the use of this Arduino Uno microcontroller? It serves us a PWM generator. Okay? PWM. And then PWM, and into the Arduino Uno, we are using a 9-volt supply battery to the voltage input of Arduino Uno. Once we already uploaded the code, we can use an external supply of 9 volts to the voltage input of Arduino Uno. This is now the supply of Arduino Uno. Also connected to the Arduino Uno is the potentiometer, 100K. The value of potentiometer or the trim pot. This is the trim pot or the potentiometer pin out. 1, 2, 3. The side view, 1, 2, 3. This is the turning knob. Pin number 1 of the potentiometer connected to the ground. Pin number 2, the wiper, is connected to A1, analog pin of the Arduino. And pin number 3 of potentiometer is connected to 5 volts. 5 volts of Arduino Uno microcontroller. So what is the use of microcontroller here in the circuit? It serves as PWM generator. And it has its own power supply of 9 volts. Okay? And then connected. What is the circuit? This is another circuit. We're going to construct this circuit composed of MOSFET IRFC44N enhancement type and channel with a drain gate source pin out. And we have here pin number 3, the output. So here, the pin number 3, since this is our block diagram, pin number 3 is this. And this whole circuit is, what is that? That is a motor driver. Driver yan, driver. If this is PWM, this one is the driver. Why we need a driver for the motor? Because the motor has a very high current. We cannot connect the motor directly to the Arduino. It will damage the Arduino Uno because this motor, DC motor, has a high current. It consumes a lot of current. Current hungry device. And then into the pin number 3, So this is where the PWM is generated. Initially, the state of the circuit is the wiper or the turning knob or the knob is located or pointing to the pin number 1, which is equivalent here, that is grounded. There is no, I think there's a small PWM that is generated into the output. Once we increase the frequency, we can increase the frequency by turning the knob clockwise. Turning the knob clockwise equivalent to the circuit of moving the wiper upward. That is the equivalent of turning the knob clockwise, moving the wiper of the potentiometer upward. So it can generate a high frequency PWM. High frequency. And then, what is the use of this 100 ohm resistor? So, this serves as the connecting resistor to the MOSFET. If we do not have this resistor, it will produce a ringing signal or ringing input or output to the MOSFET, because we need a way in which the current needs to pass. This is some sort of coupling resistor, at least 100 ohms. We need this resistor. What I mean by ringing is it will make the MOSFET to what? To ring, or making it not stable. And then we have this 10K resistor connected to the gate of the MOSFET and then to the ground, 10K. What is now the use of this 10K resistor? It serves as a biasing resistor to the MOSFET. Because the MOSFET is a voltage-driven device. Current is nothing. I mean, current is just a leakage current that are going to flow to the gate. Once the current flows to the gate, it will open the gate. But the current is not responsible for opening the gate. It is the voltage that develop in this resistor. So voltage across the gate to source, BGS, referring to a BGS, should be at least 2 volts to 3 volts to turn on this MOSFET. So the use of the resistor here is as a biasing resistor, so that we can have so that we will know what is now the voltage across the gate to source. When the voltage is developed across gate to source because of this resistor, we can now measure the voltage of the gate to source. It will now open the gate. When it opens the gate, the current will flow from 3.3 volts motor and to the drain to source and then to the ground. Then what's the use of this resistor and a diode or a LED blue? This is a power indicator or an input LED indicator. So when there's a light here, when the LED turns on, it means we are receiving a signal from the Arduino Uno. As you can see here, in our MOSFET, the gate, okay, this is the gate, and then the drain connected is the negative of the motor, then positive, connected to the 3.7 volts. This 3.7 volts is an external supply. So it means to the output side of the MOSFET, we have another supply voltage of 3.7 volts. This is 18650 battery, which is different from the voltage supply of the Arduino. We do not have a single supply. We have two separate supply, power supply, voltage supply, that is connected to the output side of the MOSFET. Once we have now this PWM generated by turning the knob, moving the wiper up, it will generate a PWM signal to the pin number 3, making it to turn on the MOSFET because there's a voltage developed here. And LED turns on, then continuously turning on or having a bright LED lights, an increasing LED light because of producing a high frequency PWM. So once the gate is open, current now flow from BDD or 3.7 volts of the battery, external supply, separate supply, turning this motor. It could be a clockwise, and then drain, then to source, and then to the ground. As you can see here, the ground of the MOSFET, which is the source, is also connected to the ground of the Arduino, since these two have separate functions. So that there's a communication between the Arduino Uno and the driver, motor driver we're going to construct. Okay, into the output of our block diagram, we have the motor. And the motor and this driver also have a separate supply of 3.7 volts. But the ground of the PWM and the ground of the driver is connected to each other. Okay? Why are we using a MOSFET here? Why not transistor, BJT? Since we're using a MOSFET, it is capable of handling a high current. So it means we can use a larger motor, a big motor, other than this. If this is a small motor, and also a big supply. It could be 12 volts, 20 volts, because the MOSFET is capable of handling, I think, up to 50 volts. And the current could be a large current. It can handle a big current to the load or to the output. So, that is the function of the speed control using potentiometer. The potentiometer is the one controlling the generation of the PWM, the output side of the Arduino Uno. When I say what I mean by high frequency generated is there's a continuous supply of PWM signal to the output, that produces a high PWM signal. And you can slowly make it to turn the motor faster or slower by turning the knob.